Hello everyone. In this unit so far, we have been talking about waves and their characteristics. All of us, all of us are familiar with waves, or we should have some experience in dealing with waves. So let's look at an example here of a man creating waves along this slinky here. So, for instance, in a moment here, you're going to see that this man, he's going to begin shaking his hand up and down. And as he shakes his hand up and down, he's going to send pulses of energy traveling through the slinky, creating several transverse waves. And that looks something like this. So, does everybody see that? So, that's an example of a transverse wave being produced within a medium or through this slinky here. So, what I want to do now, this week, I want to focus more on wave interactions, particularly wave interference. So let us look at several examples of wave interference, beginning with this visual here. Imagine that this is a long slinky, and there are two men holding the slinky. There's one man holding this end to the left, and there's another man holding this end to the right. Now, let us imagine that the man on the left, he shakes the slinky one time, and he sends a pulse of energy traveling through the slinky. And after that, the man on the right shakes the slinky one time, and he also sends a pulse of energy traveling through the slinky. So the left pulse is traveling in that direction, and the right pulse is traveling in that direction. Now, what is the amplitude of the pulse on the left? Well, let's look at this. So the midpoint of the wave is right here. So that means the amplitude has to be 1, 2, 3, 4. So the amplitude is positive 4. What about the wave on the right? What is the amplitude there? So here's the midpoint. And so we move down from the midpoint, 1, 2. So the amplitude here is negative 2. Okay, so let me ask you guys a question. If this wave is traveling in this direction with positive 4 units, and this wave is traveling in this direction with an amplitude of negative 2 units, question, what do you think will happen the moment both of these waves meet up right here at the center of the slinky? Well, they're going to interact with each other. They're going to interfere. And that wave, when they meet up, is going to look something like this. So positive 4 plus negative 2 gives me positive 2. So when those two waves meet up in the middle, they're going to interact with each other. And at that moment, they're going to produce a wave that has an amplitude or a height of positive 2 units. So this is what we mean by wave interference. Particularly here, this is what is known as destructive interference. Anytime you have a positive wave and a negative wave and you combine them, that's going to be destructive interference. Let us look at another example. So here's another slinky. So once again, we have a man on the left. He's going to send a pulse of energy traveling in that direction. And a man on the right, he's going to shake the end of the slinky, and he's going to send a pulse of energy traveling in that direction. So what is the height of this wave here? What is the amplitude? Well, so the midpoint is here. So the amplitude is 1, 2, 3. So this amplitude is positive 3. And this amplitude here, so this is the midpoint. So 1, 2. This amplitude here is positive 2. So when these two waves meet up in the middle here, as they're traveling along the slinky, what is going to be the resultant wave when they interact or when they interfere with each other? Well, this should be easy. What's positive 3 plus positive 2? So as these waves are traveling along the slinky, when they meet up in the middle, they're going to produce a single wave that has an amplitude of positive 5 units. So this is what is known as constructive interference. And the reason why we call it constructive interference is because we're adding two positive waves. So anytime you add two waves with the same sign, it can be positive and positive, or it can be negative, negative. That is what is known as constructive interference. Let's look at another example. So consider this slinky here in red. Okay, so imagine we have a man here on the left. He shakes the slinky and he sends a pulse of energy traveling in that direction. And the amplitude here is positive 2. And we have a man on the right. He shakes the slinky and he sends a pulse of energy. What is the amplitude here? The amplitude here is negative 2. So let me ask you guys a question. Predict here, what do you think is going to happen when these two pulses meet up in the middle here? When they meet up in the middle, what is going to be the resultant wave? Well, positive 2 plus negative 2, that should be obvious. When they meet up, right at the moment they meet up, that exact moment, they're going to cancel each other out and you're going to get no wave at all. This is what is known as complete destructive interference. Both waves completely cancel each other out. Now let's look at just two more examples. So here we have a slinky here in green, and the man on the left, he sends a pulse of energy traveling through the slinky, and this pulse has an amplitude of negative 4 units. The man on the right shakes the slinky, and he sends a pulse of energy traveling in this direction, and this wave has an amplitude of negative 3 units. So when these two waves meet up, what is going to be the resultant wave? What's negative 4 plus negative 3? That gives me negative 7. So when these two waves meet up, right at that exact moment, they're going to produce a single wave that has an amplitude of negative 7 units. This is constructive interference. And we know it's constructive interference is because we had two waves combined, and both waves were the same sign. One wave was negative and the other wave was negative. So they constructively interfered. One more example. So here, the man on the left shakes the slinky, and he sends a pulse traveling through the slinky, and this pulse has an amplitude of negative 6 units. And then the man on the right shakes the slinky, and he sends a pulse of energy that has an amplitude of positive 2 units. So what's negative 6 plus positive 2? When these two waves meet up in the middle here, they're going to produce a single wave that has an amplitude of negative 4 units. So this is destructive interference because we had two waves combined of different signs. One was positive, the other was negative. Lastly, I want to end this lesson by showing you guys this brief video clip that does a really good job at demonstrating historically how scientists figured out that light was a wave. And we know light is a wave is because whenever we do certain experiments, it exhibits certain interference patterns, and only waves can interfere with each other. So this video shows that by using an example from water waves. So I'm going to play that for you guys right now.
I'm really confused by it, but I'd like to find out why.
People were debating, is light a wave or is it made of particles?
So what causes that?
Well, if light were behaving as particles, you would expect them to go through each slit and just produce a bright spot underneath. So we would see two bright spots on the bottom of the box. But if light's behaving as waves, then the wave from one slit can interact with the waves from the other slit. I've got a demonstration here on a little pond where we can see this with water waves. I have two sources of ripples, which are basically like the two slits. When I create ripples with a single source, they travel out with circular wavefronts. Nothing particularly surprising there. But if I add a second source of ripples, then we start getting an interesting pattern. This pattern is created by the ripples from the two sources interacting with each other. Where they meet up peaks with peaks and troughs with troughs, the amplitude of the wave is increased. That's what we call constructive interference. But if the peak from one wave meets up with the trough from the other, then we get destructive interference and there's basically no wave there. And this is exactly what was happening with the light. When the light from one slit met up, peaks with peaks and troughs with troughs, they constructively interfered and produced a bright spot. But if the trough from the wave from one slit met up with the peak of the wave from the other slit, they would destructively interfere and you wouldn't see any light there. It's light cancelling itself out.
This is basically the same as like having 2 drops of water fall in a swimming pool.
That's right.
Get exactly the same
And then
pattern.
they go and overlap. As this ripple overlaps with those ripples, down the bottom, you get a series of, you get like a bright spot, and then a dark spot, and then a bright spot, then a dark spot, then a bright spot.
Now there's a slight complication, which is that sunlight is composed of many different colors, and they have different wavelengths. So obviously they're going to meet up at slightly different points. And that's what caused the rainbowing effects as we go further from the central maximum. You saw the ones to the right were slightly colored.
Yeah,
that's because
burgundy.
The reds are going to meet up at different places than the blues.
And that's all that makes the colour differences, is different wavelengths.
Exactly.
That's amazing.
So the difference between
So,
red and blue,
that red bin over there and the green part are just, I'm seeing
It's a
that, and it's
different-
just different
different length.
wavelength. And that's how we bring in all these beautiful colours all around us.
exactly.
That's amazing. I'm amazed. Oh, good on you. Thanks, Ben.
Hey, thank you.
I have been enlightened, literally.
So before I end this recording, I would really encourage you all to go back and watch this video through in its entirety. Just use the YouTube link here. It really is a good video for demonstrating wave interference and the various principles involved. Okay, so if you all have any questions, please don't hesitate to contact myself, Coach Davis, or Coach Larkin. Remember, we are here to assist you. All right, so have a good rest of your week. And remember, stay safe. Goodbye.